Hey everyone, hope you're doing well. In this video, I'm going to be talking about some classifications of triangles, which shouldn't really be that difficult. And then also we're going to be doing some coordinate geometry on possibly showing how a certain triangle falls under a certain classification. So you can classify triangles two different ways. The first way is by number of sides, so I'm just going to be kind of giving you the answers here. So if all three sides are congruent, hopefully you guys already know this, and if you do and you want to skip ahead, you can, but this is an equilateral triangle, okay? All three sides are equal, that's why it starts that way. If there's two congruent sides, we call that isosceles, all right? And we call those the legs, the two sides that are congruent. And if there's no congruent sides, that's called a scalene, all right? Classification by angles, all right? So if all three angles are acute, that's called an acute triangle, right? So easy enough. This one maybe you haven't heard before. If all three angles are congruent, this is actually called equiangular. And you should be able to figure out that that would mean all three are 60 degrees. And equiangular and equilateral are pretty much the same thing, right? Because one implies the other. So if there's one right angle, we call that a right triangle. And if there's one obtuse angle, we call that an obtuse triangle. So if there's any obtuse angles at all, it's going to be an obtuse triangle. Some people say, well, there's two acute, okay, but there has to be two acute. It can only add up to 180, so there can't be more than one obtuse. So classify these by sides and angles. So looking at this, it looks like none of the sides are the same, so that'd be scalene, and then this looks obtuse to me, so that'd be a scalene obtuse. This one, two sides are the same, so we've got isosceles. How do you spell isosceles? Okay, that's an S. And then they all look acute to me, so I'm going to go with the acute. I guess with the angles, you're just kind of eyeballing it, but it's all right. This one, isosceles again, okay? And then we've got a right angle, so that'd be a right triangle. For the last one, it's definitely equiangular. It says, are all sides congruent? Equiangular. Okay, I have no idea if that's spelled right. The answer is yes. So it is equilateral. I don't know if you're supposed to know that already. Now I'm like questioning how to spell everything. Equilateral. It is equilateral, okay? If it's equiangular, it's equilateral. They're both the same. So the answer is yes. The three sides of ABC are, let's do this example. So is ABC equilateral, show why or why not? So if it was equilateral, all right, that would mean they're all the same, right? So if it was equilateral, we would be able to set the sides equal to each other, solve, and figure this out. So let's do that, all right? Let's subtract 4x on both sides. Add the 4 over, so that makes 6. Divide by 2, x equals 3. So if they were equilateral, we'd be able to plug this in to all three and get the same thing. So let's try and do that. So that would make this 4 times 3 plus 2, which would equal 12 plus 2. which would be 14. Okay. This would be 6 times 3 minus 4. That'd be 18 minus 4, which equals 14. Okay, we're good so far, which we knew we were going to be good on those two. And then negative 2 times 3 plus 20. That'd be negative 6 plus 20, which is 14. Okay, so we got that one correct as well. So yeah, so all three sides are 14. So yes, it is equilateral. All right, last question. So this one's kind of the long one, all right? It says, draw the triangle whose vertices are, so let's draw this, negative 1, 1. So that's x. And then we've got 2, 3, y, and 0, 6. It says, show that it is an isosceles right triangle, all right? Now this is two parts, okay? The first part is showing that it's isosceles, all right? And in order to show it's isosceles, you have to remember how to find distance, all right? So I'm gonna go over this, all right? You know, in order to find distance, remember, let's get a different color here. You're gonna be doing the Pythagorean theorem on each side, all right? So this is up 3, and this is up 2, right? So if we wanted to find the distance of zy, that'd be 2 squared plus 3 squared equals c squared. Remember how to do this? So this would be 4 plus 9 equals c squared, 13 equals c squared. So so the distance would be the square root of 13, right? And we can do this for each side, and we can actually figure out the side's lengths. So if we do it down here, right, we're kind of going to figure out the same thing, okay, that we just did. So this is 2, this is 3. So we actually have the exact same numbers that we did before. We have 2 squared plus 3 squared equals c squared. And so all this work's going to be the same. And so again, we're going to get c equals the square root of 13. So these two sides we know are congruent. All right. Now the question to show it's isosceles, we have to show, is xz congruent? Okay. And so we can do that as well. Now you should be able to realize here, 1, 2, 3. So this one we went up 5 and over 1. Okay, so that one doesn't look like it's going to be the same. And you know, we can figure out what it is. This is going to be 1 plus 25, which equals c squared. So c squared equals 26, so c equals the square root of 26. So that one's different, all right? So we have shown here that it's isosceles. Now you're going to be doing this on your own later. So the second thing that you have to show is that it's a right triangle, okay? Now, how do we show it's a right triangle? Remember, right triangles are made by perpendicular lines, okay? And so if we look at this, okay, that's definitely not a right angle. That's definitely not a right angle. This one could be a right angle right there, right? So how do we show that it's a right angle? Well, we'd have to show that ZY and XY are perpendicular. And in order to show they're perpendicular, we have to find their slopes, okay? Now, we already have the work shown pretty much. So if we look at XY, rise over run, it's rising 2 and running 3, right? So XY's slope is 2/3. ZY's slope, so ZY is actually going down. So its rise is -3 and its run is 2. So rise over run, -3/2. And are these slopes perpendicular? Yes, right? Remember, they're flipped upside down and one's negative and one's positive. So they are perpendicular, which means this is a right angle. All right, so I know we're bringing back some old stuff here, which is good. All right, some review. So we were able to show it's an isosceles right triangle. So for showing anything about the side lengths, you're gonna have to do the distance formula. And then for showing that it's a right triangle, you're gonna have to show that the two lines are perpendicular to each other. So hopefully this helped. Go ahead and get your practice worked on. If you have any questions, let me know, and have a great day.